Welcome in this How Do I video, where I will show you how to use the time series API in Microsoft Dynamics NAV. In this video you will see how to get an Azure machine learning experiment, publish an endpoint, and use the time series API to get predictions. We'll go there by going through the following steps. In the first step, we'll create a model. In the second step, we will publish an endpoint for our model so we can access it. In step 3, we will train our model and then get predictions. And in step 4, we'll use the information to our advantage in the application. With this release, Dynamics NAV enters the world of machine learning, and the first step of this journey is to bring the time series API to Dynamics NAV developers. There is a publicly available model prepared by the Microsoft ERP team aimed at time series predictions. And then in this first step, we'll see that with a few clicks, we can create a model from a public template. So we'll use this model and we will open it in the Azure Machine Learning Studio. Then we'll copy the experiment to our personal workspace and we'll validate the experiment. To access the available model prepared by the Microsoft ERP team, you can paste this URL in your favorite browser. Once it opens, you then need to click Open in Studio, in which you will also be asked to select a workspace. You can select between a free or a standard workspace. So I will do that, and let me log in with my account. And I will now be redirected to my workspace. Here the model will open. To copy the experiment from the gallery, you can leave this on the default settings. And after a couple of seconds, our experiment is available here in the Microsoft Machine Learning Studio. You can browse around here in the model, you can zoom in, you can zoom out to have a look at the different steps. To be able to use our model, the system must now be validated, and we will do that by selecting the Run button, because we need to validate our experiment before it can be deployed as a web service. And validation is done by execution, and therefore it's enough to run the experiment once it has been imported. After the model was created and tested, we will now create an endpoint and generate an API key and a request URI so we can consume the model. We'll choose the Deploy Web Service button here at the bottom of our browser. The system will then deploy the machine learning experiment as web services and will provide a REST API which can be consumed by a wide range of services. When the deployment is finished, the web services dashboard opens, and then we need to select the request response link to open the API page. Here at the bottom, what we need is actually this URI, request URI. So I suggest that you copy it and then paste it somewhere in Notepad. Then we go back to our web services page, and here you can see the API key, which I also propose to copy. So at the end of this step in Notepad or WordPad, we have our API key and our request URI. In step 3, we will call the time series API from our development environment to get predictions on data coming from the item ledger entry table, and we'll also check the quality of our predictions before we present it to the end user. So we go in our development environment and we create a new code unit, and this code unit will call the time series API. You give it a name and a number, and then you go into the globals and you create two text constants. One is the URI and the other one is the key. And here you can paste the two values which you wrote down in Notepad. And we'll use these text constants in code to call the machine learning experiment. We'll now go to our global step again, and there we will create a new function with the name calculate forecast. In the variables of our function, we'll declare a couple of variables, and the first one is the time series library, which will help us to prepare data, submit it to Azure Machine Learning, and get back the prediction. The actual interaction is implemented as a .NET DLL, and that DLL is wrapped by the time series library variable and provides us access and CL functions to us as NAV developers. In this scenario, you would like to get a prediction for the item sales, so we'll get the trading data from the item ledger entry table. The whole task can be performed with 4 functions from our time series library variable. The initialize function will be used to set up the connection. The prepare data function will transform any table data into a dataset which is ready for submission. Then if I scroll down, what you will notice is that there is also a forecast function. This will actually call the Azure Machine Learning. It receives the predicted interval, in this case 1 month. And the get forecast function returns a dataset of the forecasted values. We will now run a forecast for this item. So I will call the calculate forecast function for that item, and then I will click the run button. The Windows client starts, and a message box will display the calculated forecast for this item. So as we can see in the message box, we can see our calculated forecast, and the system expects sales in next month to be about 3. So to summarize, we performed the task with 4 functions from our time series library variable. The initialize is used to set up the connection. Prepare data transforms any table data into a dataset which is ready for submission. Forecast actually calls the machine learning in Azure. It receives the predicted interval. In our scenario, it was 1 month. And get forecast returns a dataset of forecasted values. A question you might have is, how good is this prediction? To verify, what I will start with is I will create a list page which is built around the time series forecast table, and then in that page I will drop these fields. Now I go back into my code unit to create a calculate forecast bulk function in which we add the following code which will then run our page. Let's see what happens. This will actually run a forecast for all of the items. The Windows client starts, and the page with the calculated forecast will be displayed. As we can see in this page, we have a number of columns available. The group ID column contains the number, the item number. The period number is the predicted period number. So in the current demo, we use 12 periods of history and 1 period for forecasting. The quantity is the predicted quantity. In the current example, we didn't change it. So it's the same as in the item ledger entries. The delta explains range where the predicted value will be probability of 95%. So for this item, it means that with 95%, the sales of next month will be between 1.5 and about 5. And central point is 3.27. Let's move forward and use the received information in the application, for example, to create a purchase order. So as we can see, we create a function, create purchase order, which will create a purchase order depending on the variables which we pass. If you look closer at the functions, you notice that in this second if statement, we calculate the ratio between the predicted quantity and the delta. If it's bigger than bar, which is set as a parameter, then the system skips the line. For example, the bar is 20%, then if the system predicts quantity 100 and a delta of 90, the ratio will be 90%, which doesn't meet the bar. But the predicted quantity 10 and delta 1 meet the bar and will be processed. Basically, depending on the predictions of our model, lines will be added to the purchase order yes and no. And at the end of the function, we run and show our purchase order. Then we go into the calculate forecast bulk function, and we don't want to see the page anymore. We would like the purchase order to be created, so we modify, in this case, the code to show the purchase order. In this case, you also notice that our quality bar parameter has been set to 0, and this means that the system will ignore deltas when it creates a purchase order. We'll now run our page, which will open the client and display the purchase order. And as you can see, the purchase order has now been created. And in the purchase order, we see 2 lines for 2 items with the predicted quantity, which is coming out of our machine learning model. Let's summarize our steps. We started by creating a model in machine learning. We published an endpoint so we can access it. Then we trained our model and we got some predictions out of it. And then we used the information to create a purchase order. In this video, we covered the basics of the time series API and also using machine learning or predictive analysis. To learn more, please visit the following resources. Thanks for following this short video to explain how to use the time series API to get predictive analysis in the application. This video in the How Do I series for Dynamics NAV is brought to you by Microsoft and Platan. See you in the next one.